error detection and error correction. Okay, fine. Guys, if you observe in the systems, the data is going to store in the form of binary format, that is in the form of 0110, or we can call it as binary format like zeros and ones. Okay, fine. If this is present in the system A and I would like to send this data to another system over the network, at the receiver end my data should be like 0110 only, right? But sometimes because of something happened, because of breakage in the linkages, because of some kind of some problem, this data may be modified and it can be received like this. It can be received like this, right? So as sender is sending 0110, receiver is getting 0111, which is actually incorrect with respect to sender, but receiver don't know. And receivers think that this 0111 is also correct, right? This is what I can call it as an error, right? So error means simply a change in the sending data. I can call it as error. Because of this error, the complete result also going to be changed, right? So if you observe, it is assuming that it's a binary data, binary number system. So 0110 means its value is 6 and its value is 7, right? Even I am sending the value 6, but my receiving side I am receiving as 7, so I can call it as change in the error, right? Okay, so here if you are able to send 0110 and you are going to get 0110, that is perfectly fine. Okay, but the question is, when there is an error, when there is an error, when I am trying to send 0110, and if I am able to detect that there is an error in the receiving side, if I am able to detect that there is an error in the receiving side, I can call it as error detection. Means whatever data that I am trying to send, that will be sent perfectly. In the receiving end, I can able to detect there is an error. We can call it as error detection, meaning that you can simply say that you know that where the error is, right? At the receiving side, you have known the error. At the receiving side, you know the error. It should be you know the error. At the receiving side, you know that the error is there. That is what I can call it as detecting the error, right? And coming to error correction, you know error is there and you have to find out uh, where the error is there. There is a difference between these two. Okay, meaning that, see, observe, by simply looking at this particular example, when I am sending 0110, the receiving side is 0111, right? So now you simply by using some procedure identified that yes, at the receiving side there is an error. At the receiving side there is an error. That is what I can call it as error detection. Whereas coming to error correction, at the receiving side you know that error is there, as well as you identified that error is at the first bit. So if you are able to toggle this number to 0, then I can call it as actual data. So if you would like to toggle the actual bit, then you have to know the where the error. That is the difference between error detection and error correction. Okay, in the reality, you can able to perform error detection in many ways. Like, let us check that, right? Error detection means simply we will know that error data is received, right? So for example, if I am saying that 0110 0111, right, this is received. So there is an error detection. How many bits are changed here from this to this? Only one bit is changed, right? This is what I can call it as one bit error detection. One bit error, right? As there is an only one bit in change of error, I can call it as one bit error detection. Okay, fine, guys. So in the reality, if I am going to have the data like this, 0001, 0001, at the receiving end, if you are going to receive 4 zeros, how can you able to find the this receiving error, receiving end, this data is error? Is it possible to find? No, it couldn't possible. If you think like I am trying to change only the second bit as it is, can you able to identify there is an error? It couldn't possible. 0101, is there an error? Yes, of course, by simply seeing from our end we can able to, but what about system? It is not possible. 1001, yes, there is a one bit change, that is this change, this 0 I modified it to 1, that's why I can say that there is an error. But with respect to system, how can you identify that there is an error in the receiving side? It couldn't possible, simply. Okay, fine. So okay, leave it this one. So if I give some kind of BCD system, if my transferring data system is following BCD system, I am trying to send a data called 1010. Is it possible in BCD system? I can able to change, right? Yes, its value is, okay, this should be 1001. Okay, its value is 9. Yes, in BCD system 9 is valid one. Okay, at the receiving side, if I got one bit corrupted, that is like if this 0 is changed to 1 and this 0 is as it is, this one is also as it is, right? At the receiving side, the data is modified or not? Yes, modified. I can able to identify it because in valid BCD system, its range is from 0 to 9 if we are going to have 4 bits. But here you got as 1101, which is beyond the range of 0 to 9. So I can say that there is an error detected. There is an error detected, right? But in BCD system, it is possible. What about in the normal processor? Even if there is one bit change, it couldn't possible to find out the error. Okay, for that, the thing is, if you are able to observe here the point, why I am easily saying that there is an error detected, because I followed certain kind of pattern. What is that pattern? The range of receiving data should be 0 to 9. 0 to 9, right? Yes. See guys, don't think about this point, right? 1 0 1 1. Again, it is also leading to more than 9 only. Okay, with respect to this bit, this is also an invalid BCD code. Okay, for example, my sending bit is like 0001. If it is modified like 0101, now it is also invalid in BCD system, right? Invalid means there is an error detected. There is an error detected. Even with respect to BCD system, it is valid, but according to this one, we can say that there is an error detected. But error detection here also it is not possible. It is also not possible. The thing here you have to understood that is there should be certain kind of pattern. If you are able to find out, then you can able to easily detect the data, right? So if I am going to have the data like 4 zeros, 4 zeros, guys, if there is certain change in these bits, obviously all those change will be comes under either 0001 or 0010 or 0100 or 1000. Any one of these four changes, see, I am trying to say out only one bit error detection. If any one of these four changes will happen, then I can say that one bit error detected. One bit. But for system, how can it do? No, right? It couldn't possible. So what I will do now, I will make the certain patterns where the next patterns is like 0011, meaning that there is 2-bit change. I have changed it to 2 bits, or I can modify it as 0110, right? I modified it to 2 levels. Okay, or I can modify it as 1100. If you observe these two, the distance between these two is 2. Distance means what, you know, right? How many number of bits are changing? This 0 is 0 as it is, 0 is 1, this 0 is 1. What about this one? This one is also like this. Okay, so the distance between the each and every pattern is 2. The distance between each and every pattern is 2. Now Suppose that when whatever data that I am trying to send, that data contains the distance between them is 2, right? Suppose for example, if I am going to receive the data like some one bit modified, obviously it is going to be placed any one of this equation. If it is 0001, it will be comes under here. If it is 0010, 0010, it may be find here only. 0010, it may be find here only. If it is 0100, it may be find here only. If it is 1000, it may be find here only. Meaning that when you find there is a pattern, that is distance between the two valid data is 2, then whatever the data that I am trying to send, if there is 1 bit error, then automatically I can able to find that error. Okay, fine. Observe guys, if it is 0011, if it is modified to some other thing like 0, 1, 1, 1, is it a valid data? No. Green reference valid data, red reference invalid, right? Is 0311 existed in the green pattern? No. So I can say that there is an error detected. So for example, if this error 0110 is modified to some other data 0, 1, 0, 0, 0. Is 0100 is existed between these any one of the 4 green colors? No. Obviously there is an error detected, meaning that when you say that distance between two valid patterns, distance between two valid patterns is 2, I can able to easily find out 1 bit error detection. 1 bit error detection. Similarly, if you generalize it, if the distance between uh, something like if you take two valid patterns, if you would like to identify 2 bit error detection, then compulsory the distance between these two should be 3 bits. I mean, if there is saying that two valid patterns are there. If you would like to find out 1 bit error detection, what is the distance between these two? Compulsory this is 1 and this is 1. So 2 bits. 2 bits. Similarly, if I am trying to say that if you would like to find out 2 bit error detection, compulsory required 3 bit distance. 3 bit distance. Okay. So if I am going to have to find out t bit error, compulsory you required greater than or equal to t plus 1 distance. T plus 1 distance between the two valid patterns, then only I can able to find out the error existed or not. Okay, fine. Next one, that is error correction. Okay, so coming to error correction, once you know that where the error is, you can able to correct it easily. Right? Yes. So the thing here is, so if you would like to see, if I am going to have the data patterns like 0001, compulsory if the valid patterns are like, if you think that it is 2 bit distance, the data should be compulsory 0010, 0010, right? So why I am saying that it is 2 bit distance, because there are 2 bits are modified, so this is 2 bit distance, right? As there is a 2 bit distance, I can able to simply define whether there is an error or not, right? Because it patterns are different. But the thing is, for example, if there is some modification between here, there is some modification, that is 0011, right? So between I modified data like 0011, because of some problem 1 bit is modified. Yes, I can say that with respect to the patterns what I am going to have available, I can say that there is an error detected. Okay, see, to make it clarity, I will write once again. For 0001, What are the valid patterns? 0010 is one kind of valid pattern. What is another kind of valid pattern? 1101 is one kind of valid pattern, because I made these two change. These two are similar, and I think 0111 is one kind of valid pattern, right? Other than these four, if you got any kind of data, we can say that there is an error detected. You can error detected, right? But the point here is, if you are saying that there is an error detected, there is an error detected, but my question is here, error correction. You have to know where the error is, right? You cannot able to exactly define where the error is with respect, right? With this data you can say that there is an error, but you cannot able to say that where the uh, correction I need to do in order to make it valid data, right? So whether I need to modify this data to this bit to 0, this bit to 0, or whether I want to modify to this bit to 0, right? That is your question. That is your question. That so because of the reason, what we can do now, why I cannot able to correct here, because the distance between now the sending data and the received data is 1. The distance between some other pattern and the received data is 1. So as both are having the same length, I cannot able to justify that, right? Where the bit is modified. So this is the reason you can able to increase the distance between two valid patterns, that is 0001 and if you are able to like increase the distance between these two, right? If I am saying that, that is for example 110, I am trying to increase the distance between the two valid patterns is 3. I'm trying to increase the distance between the two valid patterns is 3. If I'm going to increase distance between two valid patterns is 3, if there is any 1 bit error, that will be placed here. That will place here, right? And if there is any 1 bit error, if you thought, that is going to be placed here. If there is one more bit changes, that is going to be available here, right? Meaning that 0000, I got this one, right? Now I got the 0 instead of 1. I can directly say that obviously this particular data 4 zeros is not available in my pattern. Am I right? Yes. See, if you want, you can understood 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. And so on, right? If I am going to have 4 bits, actually how many patterns are possible? 16 patterns are possible. 16 patterns are possible, right? If I am going to say that this 0 is a valid pattern, 0 is a valid pattern, if you would like to detect the error, compulsory what is the distance between the two valid patterns? If you would like to detect the error, if I would like to detect 1 bit error detection, compulsory the distance between the two valid patterns is 2, right? If I am saying that distance between two valid patterns is 2, compulsory for this one, what is the invalid pattern? 0010, sorry, this is 0011, 0010, and if I am going to modify third bit, it will comes under array. If I am going to modify uh, the next one, that is 1, right? Obviously if I am going to consider 0 as a valid pattern, 1, 2, 4 and 8 are invalid patterns. So if I am going to say that these 4 are invalid patterns, then only I can able to identify that there is a 1 bit error detection, right? So meaning that if I am going to have 1 as a valid pattern, obviously 0 will becomes under invalid pattern. When there is an invalid pattern, okay, fine, right? Now I identified that there is an error detected. There is an error. How can I say that error corrected? Because see, this error is detected here, right? Now I can easily say that where the error is there. So as this is nearer to this one, I can say that at the sender side itself is error is there. So I can simply modify the respective location as 1. For example, at this particular side, like if it is 011, sorry, if you got like this, now here also there is 1 bit error only, with respect to this one, right? 1 bit error only, but is it nearer to this one or this one? It is nearer to the receiver side. So you can able to easily correct it. Correct. Okay, fine. So here the point is, so if you would like to correct, if you would like to correct single bit error, single bit error, the distance between two valid patterns should be 3. The distance between two valid patterns is 3. If you would like to correct 2 bit error, 2 bit error, the distance between two valid patterns should be 5. Similarly, if you would like to correct 3 bit error, the distance between two valid patterns should be c. So, right? So if you simply generalize, if you would like to correct t bit error, the distance between two valid patterns is compulsory greater than or equal to 2t plus 1. This is what you can able to generalize with this example. Okay, fine. So here I made it corrected, right? I made it the correction, right? Because of this, the distance between, see, observe, see, this is 1 and this is 2 and this is 3. So 1 2 3. Okay, fine. So in reality, if you are able to observe this data, if you are going to have 4 bits, you are going to get 16 patterns. Out of the 16 patterns, if I am going to select one pattern, you are going to remove by 4 valid data, 4 data removed, right? Now if I am going to select 3, again you need to remove the sum of those, remove some of those, right? Because there should be gap of 2 valid pattern, there should be gap of 2 distance. That's the reason. So in this particular procedure, what the procedure that I have discussed up to so far, so that particular procedure cannot able to achieve at least the data from 0 to 9 itself. I cannot able to get 10 patterns, 10 patterns easily in order to accommodate 0 to 9. So that's the reason this is a difficult procedure, and that also it won't satisfy various kind of all kind of requirements. That's the reason, we'll move with another kind of error detection mechanism, that is parity bit mechanism. See, earlier procedure what I explained is also one of the procedure where we are going to identify the patterns, and then we are going to define whether there is a detected, whether there is error in the receiving side or not. We are going to detect. But the thing is, this procedure is a hectic procedure, and also we cannot able to accommodate more number of values. So that's the reason we are moving for one kind of error detection, that is parity bit. Another kind of error detection mechanism is there, checksum. Another kind of error detection mechanism is there, cyclic redundancy check.